Hello, my name is Casper and I want to talk about a design pattern called CQRS. I've read an article written by Martin Fowler and he's describing what CQRS is and when it's useful to use. So in this presentation I will go over the keynotes about Martin Fowler's points in the article, and further I will make a demonstration in an example. So the first thing, what is CQRS? CQRS stands for Command Query Responsibility Segregation, and it is a part where you separate all the logic compared to a command and all the logic compared to a query. By dividing this segregation, you can do a lot of business logic in your application and increase the maintenance. So first I want to talk about what a command are and what a query are to understand this design pattern. A command is simply a task the system should do. Like if you say you want to tell the system to book a hotel, that would be a command. And if you tell the system to like create a user, this will also be a command. The key thing about a command is it doesn't have a return value. Command is often a create command, a delete command, or an update command, because these don't have any return values, so you can use the CQRS design pattern with these. The thing about these commands is they are typically bound to a database interaction when they need to like delete a row, update a row, or insert a new row in a database. A query, on the other hand, is used to retrieve information from the system. A query could be like get all the hotels in the system, or it could also be used as get a user by ID. The key thing about a query is that it returns some data from the system. Since queries only retrieve information from the system, they are often faster than the commands in the system because they don't have to do any business logic to the system. So this is like a regular system where we have the UI. The user can make a change in the UI. Afterwards, the changes is forwarded to the model. The model executes information and validates the request. Afterwards, the model sends updates to the database. Other words, we can also have a UI a user make a request from the UI, then the model reads from the database, and the information is passed to the UI again. You can see here that we have like the model is both doing like the request and the command in the system. What this design pattern actually gives us is a segregation method to like split the application in two, so we can have like the query and the command in two different pipes. Here we have the same system, but here we use a CQRS command pattern. You can see the difference that we now, instead of have a application model, we now have a command model and a query model. And then we have interfaces between these to interact with. Now when a user makes a change in the UI, the application routes the change information to a command model. This command model can then do all the business logic in the system, and then afterwards send the information to the database. And then when the model reads from the database, it is only the query model that has access to read from the database. And then all the information is then passed to the UI again. This increases the maintainability in the system. So actually, what do we get from using this design pattern? Martin Fowler talks about that when we have this design pattern, we can increase the scalability, because if there's a huge load on the query part and not the command part, we can scale them separately. Also, it increases the simplicity in the system because each model is only responsible for the thing it has to do. And lastly, it increases the performance in the system because a command is usually more a load on the system because it has to do all the business logic, and the query is usually faster because it's only reads from the database and don't require any business logic. On the other hand, this also gives us some drawbacks from using this design pattern. You have to have a solid knowledge about the design pattern, because if you don't have, you will increase the complexity in the system, and though you will not benefit from the benefits this design pattern has at all. So I want to extend this article with another design pattern called the mediator pattern, because CQRS pattern goes very well with media pattern and is often used in large enterprise applications. So I just want to talk a little about what the mediator pattern is. The mediator pattern is very good at increasing the cohesion and lowering the coupling, because classes that need to communicate with each other can communicate through the mediator, and though they don't have to have any coupling between the classes. As you can see on the UML diagram, we have a client and then we have the mediator. Every time the producer wants to notify the consumer, it goes through the mediator, and then the mediator handle all the communication between the producer and the consumer. This is very important because when we're using this design pattern with the CQRS design pattern, we get a very, very solid system and a very, very quality code base. Lastly, I want to show an example how you can use this design pattern in an enterprise application written in C#. API is. A web API is simply an application that smartphones, browsers can communicate with, so it isn't bound to any specific like browser or desktop application or a mobile phone, and the web API often communicates with the database. So this is an example where we have a web API. This web API is written in C# with ASP.NET Core. The CQRS command pattern split the commands and the queries up. And the mediator pattern is like this communication pattern where two classes can communicate without having any knowledge about each other. So let's take a query, for example. Here we have a controller called products controller. Then we have like a get product. This uses a mediator class to send information, and it sends information called get product query. By using this mediator, we don't have any knowledge about the class that retrieved this information. We simply just send the information to any class. So it's lowering the coupling in the system because these controllers don't have any knowledge about any other system in the system. And then if we go into the products here, we can see the queries like get product and get product query handler. Since this class has the interface iRequestHandler from get product query, the mediator knows that this is the class that the other class is communicating with. And here we have a query that's simply retrieving information from the database and then returning the request from the database. On the other hand, we can also have a command. So this is like a create product command. We still uses our media to send the command, And you can see here we have commands, create product command and create product command handler. And since it has the interface iRequestHandler, and it knows that it has to communicate with the other class, create product command, this is simply all the information that is bound to the mediator request. So in this situation, we can use all our logic, business logic in here. Here we are converting the request to an entity in the system, and then we are adding it to the database. And we don't return any database or models at all with these commands. So simply by using this CQRS command pattern, you can split up the commands and the queries in the system, and you can scale them independently. This increases the maintainability in the system very much. Lastly, I just want to show an example. So here we have the API. And we can simply testing if we want to test the product and create a product. This is a post command. I want to set a breakpoint here to demonstrate. So now we hit this method create. This method knows that it should use the command pattern instead of the query pattern, and it sends all the information from the request, HTTP request. It uses the mediator to send out the information in the system, and since it's using the mediator, it has very, very low coupling because it doesn't know about any other classes than itself. You can see here the next part we hit is the handler, and now we are able to do all the business logic in our system and then return the ID of this product. This is a very, very clean architecture and a very clean design pattern, and it increases both the scalability and the maintainability in the system.